Okay, section 2.5. In order to kind of really get where this is going, I want to lay some groundwork by reviewing some things that you probably already know. Like, for instance, perimeter just means the distance around the outside. So for a square that has a radius r, that would be 2 pi r. And for a rectangle that has, like, let's see, a width, that length, and a length L, it would just be 2w plus 2l. For a square, if one side is x, then they're all x. So that would just give you 4x. And then if you have a triangle like this one, if they're all the same angle like this, then the outsides are also the same. So then the perimeter would be 3b. Area is like the distance, the area to cover. It's like the amount of paper it takes to cover it. So what covers the object? So for a circle, also with radius r, that's just going to be pi r squared. And then if we have this same rectangle with a width w and a length l, then the area is just going to be w times l. And for a square, if one length is x, then they're all the same because it's, a square. Then the area is going to be x squared. And then if we have a triangle like this with a base of b and a height of h, the area will be 1/2 base times height. So surface area is the same thing. It's what covers the object, but one is 2-dimensional and one's 3-dimensional. So this is a 3D kind of thing, and area is a 2D type thing. So for surface area, to figure out what's going to cover this whole object, one part of it is a circle. So I know I need a circle for the top and a circle for the bottom. So the surface area of a circle is pi r squared. So I know I've decided that this radius is r. So I have two of them, one on the top and one on the bottom. And then let's say this is a height h. Then if I were to take this like can and like cut it right here and then unwrap it, I would get a rectangle with a height of h and then the length around here, which would just be the perimeter, which is 2 pi r. So I get plus 2 pi r times h to get the area. And then for this box here, let's make all of these L. And there's like an invisible L back there. And then we'll make it this wide, that wide. And then these ones will make H, this H, and this H. So to figure out the surface area of this one, it's like a little bit trickier because we have, let's see, this box right here, there's two of them. There's one on this side and one that we can't see on the back. So that'd be 2LW. Oop, that's not exactly what I meant to do. I meant to erase this part. And then for this box here, there's also two of those. That's 2 times length times height. And then there are two of this top box. The top box up here would be W times H. So I'm basically just finding the area of each side and then adding it all together. Area of a cube is a little bit easier. if one of these is an x, then they're all a length of x, so it's just x cubed. Oh, I'm sorry, I'm starting to do area, which is not what I wanted to do. So to find the area of one box, that would be x squared, the area of that one box, but there are 6 of them, 1, 2, the one on the back, one on the bottom, and then front and back. I don't know how you want to work that out. So I think it would be 6x squared. And then last but not least is a sphere. And if the sphere has a radius of r, then the surface area, I think, is 4/3 pi r cubed. But I actually have to check my notes because I don't remember. So my notes say, they say 4 pi r squared. So I was not close. Oh, this must be surface area. I mean volume. 4 pi r squared. Cool. So I've done my surface areas. Last is volume. It's the amount to fill the container. So for each one of these, some of them are easier than others. So if this is L and this is W and that's height, well, the volume of that is just length times width times height. And then for a cube, if one of the sides is x, then it's just x cubed. And I just looked this one up because I got it mixed up. This one with a radius of r is 4/3 pi r cubed. But this one on the left is a little bit tougher. So we have a volume here, but there's a circle at the bottom which has an area of, let's see, we said this was pi r squared. And then we'll say it's h tall. So if we actually just multiply this by h pi r squared, then we get the volume, because we're kind of like stacking the circles up on top of each other, h high. So you might be wondering, like, why did we do that? Why did we figure out what all of these different things are? What's with this review? Well, in this section, what we're going to do is think of ways to optimize objects. And some of the objects that we'll optimize will be cylindrical or spherical, or maybe they'll be circular. So we need to remember those equations. Okay, so I'll give you a minute to look over this, make sure you have everything filled in your notes, because you will probably need it. And then we'll meet back at the next problem.